All right, guys, let's look at some problems from the homework. At the top of page 3, you were given a chart and some information. It says that Jacob decides to save money for a new tablet. He will save $3 the first week and then triple the amount he has saved each week for 5 weeks. And it's asking you to write and evaluate an exponential expression. So they've given you the table. They're showing you each week. Notice that at week 1, his exponent was a 1. At week 2, his exponent was a 2. At week 3, he had a 3 for the exponent, and so on. So then they even showed you week 5, it would be 3 to the 5th power. They evaluated it and found that at $243 in week 5. So if you look at question 2, it says, how much will Jacob have in his account in week 3? So if we do what was done for week 5, 3 to the 5th means 3 times 3 times 3 times 3 times 3. Then if I'm looking for week 3, and it says 3 to the 3rd power, that means 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. So that is the amount that he will have in his account at the end of week 3. All right, keep that in mind, because for number 4, it says that Margot's dad offers to give her 5 cents on Sunday. Then for each day of the week, he offers to give her 5 times the amount from the previous day. How much will he give her on Saturday? Write an expression to show how much Margot's dad gives her on Saturday. So if we had a table, as we did on our example, it would look something like this. On Sunday, she would have had 5 cents to the power of 1. On Monday, 5 cents to the power of 2. On Tuesday, 5 cents to the power of 3, and so on. So by Saturday, which is what our question is asking, we would have had 5 cents to the power of 7. Okay? So doing 0.05 times 0.05 and so on 7 times can get a little confusing with our decimals. So to make it easy, we find what 5 to the 7th power is, and we don't have our calculators yet, so that's why we wanted to help you with this one. That would be 78,125 cents. Now, of course, he's not giving her $78,125. That's in cents. He's only giving her 5 cents, so we have to convert that. So because of our place value, he's actually giving her $781.25, which is still pretty great. So that should be your answer there. 5 to the 7th is your expression, and then on Saturday, $781.25. All right, now let's look to the next page. And we want to look at number 6 for just a moment. Number 6, it gave you the information that the bacterium cells split into 2 cells every hour. It says to write and evaluate an exponential expression to find how many cells there will be in 6 hours. Then use your answer to help you find the number of hours it will take for there to be 1,024 cells. Now again, we don't have our calculators out yet, so that's why we wanted to work through with you. But let's think about what our problem is telling us. It says that at the end of 1 hour, we will have 2 cells. So at the end of 2 hours, we have 4 cells. So the end of 3 hours, we have 8 cells. So if you look at your pattern, the amount of cells is doubling. Okay? So 2 will be our base. We're getting 2 cells every hour. So I could write that as 2 to the 1st. So 2 cells for the 1st hour is 2. 2 cells for the 2nd hour is 4. 2 cells through the third hour is 8. 2 cells through the fourth hour is 16. You can see my pattern. I'm just doubling my numbers. So 2 to the 5th is going to be twice as much as 16, so that's 32. And 2 to the 6th. So in 6 hours, they will have 64 cells. So that is one of your answers. It said right here, cells there will be in 6 hours. Okay? Our other question was, then use your answer to help you find the number of hours it will take for there to be 1,024 cells. So we're going to keep going, and we're still just doubling our number. We don't expect you to know that 2 to the 7th power is 128. But if you double 64, you can find that number. So 2 to the 8th power, if I double 128, I get 256. 2 to the 9th, so I'm doubling my 256, I get 512. And 2 to the 10th, if I double 512, I get 1,024, which is the number we wanted, so it takes 10 hours to have 1,024 cells. Okay? And when it says show your work, this is your work. This is what your paper should look like. Okay? Let's look down at number 8. Now 8 is very similar to our journal when we were talking about square roots. I know for my classes we also put in there cube roots because those we talked about what number gets multiplied 3 times to find a number. So this is the same idea. They're just working backwards. So it says write each of the numbers 1, 8, 27, 64, and 125 as a base raised to the third power. So they're asking you what number times itself 3 times gives you 1. 1 does. 1 times 1 times 1 is 1. All right, what about 8? That would be 2. 2 times 2 is 4, times 2 is 8. All right, 27 is 3. 3 times 3 times 3 is 27. 64 is 4. 4 times 4 times 4 is 64. And 125 is 5. 5 times 5 times 5 is 125. So I could ask for the cube root of these numbers, just like we asked for square roots the other day, to find this. All right, now let's look on the next page. You also had page 5. Number 2 and 3, pretty simple, just applying your rules of exponents that we talked about the other day when we made our power bar and we've done the examples. Number 2 says to simplify 7 to the 5th raised to the 6th power. And it says write your answer using an exponent. So I don't need a calculator. All I need to know is that the rule for raising a power to a power is to multiply the exponents. So I'm just going to do 7, and 5 times 6 gives me 30. So 7 to the 30th power. All right, now number 3 is a little different. We have 6 to the 3rd times 9 to the 3rd. Now we talked about if your bases are different, 6 and 9 is different, but your powers are the same, you keep the power and you multiply the base. So I'm going to keep the 3, that's my power, and 6 times 9 is 54. So 54 to the 3rd power would be my answer. All right, a few more. On the next page, we're looking at number 9 and 10. All right, number 9 says, without evaluating the expressions, tell which is greater. So you've been given 4 to the 4th times 5 to the 4th. Now we just looked at a problem that didn't have the same base, but the same exponent. So we said, keep the exponent, multiply the base. So 4 times 5 is 20, and we keep the 4. Same thing here, 2 to the 5th times 10 to the 5th. The bases are different, the exponent's the same, so keep the exponent and multiply the base. So 2 times 10 is 20 to the 5th. It says tell which is greater, 20 to the 4th compared to 20 to the 5th. 20 to the 4th is smaller. All right, so we have put 20 to the 4th is less than 20 to the 5th. It says to explain your reasoning, and we've pretty much done so with just our numbers. We know that if they have the same base, the larger the exponent, the bigger the number. So that could be the explain your reasoning. All right, and then the last one, number 10, it says Nicholas says that 2 to the 6th times 2 to the 6th equals 2 to the 12th. And also equals 4 to the 6th. Do you agree? All right, well, let's look at it. 2 to the 6th times 2 to the 6th. When we have the same base, we can keep the base and add the exponents. So 6 plus 6 is 12. So I would agree that that equals 2 to the 12th. And it says that it also equals 4 to the 6th. So our other rule says that if the bases are different, but they're not, but our exponents are the same, that we can multiply our bases and keep the exponents. So if I multiply 2 times 2, I get 4, and if I keep the exponent, I get 6. So yes, we would agree with Nicholas that those are equal. It happens rarely, but that will work for this case. All right, guys, good job.